This is one of the largest helium balloons in the world, moments before it attempted to capture the most precise 360-degree image ever shot in space. And this is us, Team Dorothy, a group of artists, filmmakers, and engineers making immersive films so anyone can experience the overview effect, the profound sense of clarity astronauts feel when they see our planet from space. It took us 7 years of research, dozens of stratospheric flights, and 7 generations of our own flight module to take on our biggest challenge yet, sending a high-resolution cine camera into the stratosphere, the Insta360 Titan. We thought being selected for this mission was the hardest part, but what we didn't know was that it would become the most technically complex mission we had ever attempted, and that failure was never far away. But before we get there, let's rewind. Because the real question is, how did a small team of filmmakers end up working with the French and Canadian space agencies? In 2024, a total solar eclipse unfolded across North America. That day, we had an idea. What if we could reverse our point of view? What if instead of looking up at the moon, we could watch its shadow move across the Earth but from the very edge of space? To tackle this challenge, we built version 7 of our module Dorothy. Not that one, this one. Equipped with an action cam and a GPS, we attached Dorothy to a helium weather balloon and let her rise into the stratosphere. 35 kilometers above the ground, Dorothy captured the eclipse and went safely back to Earth attached to a parachute, carrying the precious footage with her. These extraordinary images caught the attention of the Canadian Space Agency. They agreed to help us send the Titan to the edge of space. But to carry this heavy-duty tech, we had to build our most complex and robust module yet, Dorothy version 8. We chose the Titan because we wanted to capture the highest possible resolution images from space. But there are many technical challenges. First, the heat generated by the camera's motorboard. On Earth, electronics mainly dissipate heat by convection using fans. But in the stratosphere, the air is about 150 times thinner, making this cooling method totally ineffective. Second, the flight lasted 14 hours, and the light would change a lot, so we needed to be able to remotely adjust the camera settings. And finally, we needed a way to reboot the camera in case of a system failure. The space agency uses an aluminum gondola to carry scientific experiments into the stratosphere. Most of the time, the instruments are mounted inside the gondola, well protected from radiation, extreme temperatures, and rough landing. But in our case, we wanted to capture a clear view of the Earth, so the camera had to be mounted outside the gondola. Ultimately, this dictated the design of Dorothy 8. Let's build it. The agency required that every structural element withstand 7G. 7 times the force of gravity. The same kind of acceleration jet pilots experience during extreme maneuvers. We therefore had to simulate this force across all critical structural points to achieve flight certification. Once the structure was completed, we worked on building the electrical and onboard computer system that would power, monitor, and control the Titan.
On prépare Ariane 5. Câble USB comme ça. Bye.
We also developed a program that gave us remote control of Dorothy from the ground. The Titan was repainted with the same space-grade coating used on the International Space Station. This special paint significantly reduces solar radiation and maximizes radiative heat loss, allowing the camera to withstand the extreme temperature difference between the sunlit side and the shaded side of the gondola. It took us 8 months to design, build, and test Dorothy. Once we got our flight certification, we finally traveled to the launch base. Arriving on site, the first thing we did was wait and integrate Dorothy on the gondola next to the other scientific experiments. We also performed what we call end-to-end tests to ensure that all systems operate correctly and that the scientific experiments don't interfere with each other. After 4 days of integration, we rolled out to the launch pad. The main balloon was filled with 2,000 cubic meters of helium and would reach 70 meters in diameter at full expansion. That's roughly the same size as the Statue of Liberty. The membrane was 25 micrometers thick, about 3 times thinner than a human hair.
Dorothy, ready for launch. I repeat, ready for launch. All personnel, this is control. Clear the launch pad immediately. All systems are green. T-minus 5, 4, 3, 2, 1, release.
On s'écarte. Et vous lâchez, vous poussez. C'est bon, ok.
During the ascent, all the systems were nominal, and Dorothy sent us the first live image from the Titan. The agency and the other scientists were pleased to have, for the first time, a 360 live view from the gondola. 8 months of work, countless design iterations and testing, all leading to this moment. We felt like we were finally reaching our goal. And then, just a few minutes after reaching the ceiling, 32 kilometers above the ground, we had...
On a perdu la connexion avec la caméra.
Ok. Vous voulez savoir? Pourquoi on la voit pas?
On la voit pas. Si on est en erreur, il n'y a peut-être plus du tout d'interface réseau.
Vraiment eu une erreur qu'on n'avait jamais vue. Et là, on a pris la décision d'essayer le moteur.
Let's pause to fully understand what is happening here. We have now been without contact with the Titan for over 40 minutes. At this point, we have no idea of what's going on board. We've tried everything, nothing works, and slowly we reach our last option, to shut down the power and reboot the Titan using the push button. But this operation comes with a risk because if we shut down the power and the push button doesn't work, it's the end of the mission. There would be no way to turn it back on.
Je vous demande de couper Dorothy. Alimentation coupée. Vas-y, Greg, redémarre le système.
C'est parti. La température est en train de chuter.
Vas-y, refais un check state.
Toujours pas de réponse.
Ouais, c'est beau, hein. Incroyable.
After a 14-hour journey through the stratosphere, Dorothy landed safely back on Earth in the stillness of the night. The retrieval team still had to locate and recover the gondola and bring the Titan back with all the footage. In the vast and remote Canadian backcountry, this was no easy task.
All right, the GPS says 300 meters east.
Let's go.
I found it.
The camera is what is holding the whole thing.
We're ready, you can drop the payload.
We feel so privileged that the French and Canadian space agencies believed in our vision and helped us succeed in this mission. The footage we captured serves two purposes. One, advancing science by contributing to an experimental research program led by the CNRS, France's leading scientific organization. And two, pushing the boundaries of immersive storytelling by creating a science fiction film based on the real footage from the stratosphere. At its core, the Dorothy Project is about wonder, about how extraordinary perspectives can reshape human perception. From art to science, from engineering to exploration, this mission marks a new step forward for the Dorothy Project, and this is only the beginning.